Okay. Properties of a rhombus. So Audrey has a favorite quadrilateral, the rhombus. Even though rhombus is defined as having four congruent sides, she suspects that the sides of a rhombus have other special properties. So explore, mark the sides as equal. Okay, that's not hard. Just do little markings. I know. I know. It's a lot of different packets. I think you're right. Okay. So what else can we say about this? About the sides? What else? Faith, good. Yep. You have two pairs of parallel sides. So PQ is parallel to SR, and PS is parallel to QR. Yeah, these are parallel markings. Sometimes I slant them, sometimes I don't.
But you feel like on the parallel.
Oh, no, 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 those are congruent. If you want to do parallel markings, then you do this. Uh, so the definition of rhombus is all four sides are congruent. We assume that to be true. So that's the pure definition of rhombus. It just so happens they're going to be parallel as well. So she knows congruent triangles can help prove the properties about quadrilaterals. She starts by drawing it. Excuse me. Um, starts by drawing a diagonal, generate congruent triangles, and then we got to do some proof stuff, right? So that's what we're going to do. So let's go ahead and do that right now. Okay, I think I got this position just fine. So I'm going to draw this. So what do I want to prove? I want to prove. So what am I given, by the way? I'm given, hold on a sec. PQRS is a rhombus. So we're going to do this very formally. And what do you want to prove? Well, they said so. That triangle PSR is congruent to triangle RQP. Okay, so that's when I write my given statement. PQRS is a rhombus. That's given. Now, this part may not be obvious, but we do know that PS is congruent to QR. And at the same time, PQ is congruent to SR.
Is that like that?
Yeah, exactly correct. Right. I mean, they're all the same, but I'm going to be deliberate about the pairings so I can do the triangle congruence. Yeah, you're going to quote the definition of these shapes off, like definition of a kite, definition of a parallelogram, definition of a rhombus, definition of a square, definition of a rectangle. You're going to be quoting these a lot. Yeah, that's the definition of a rhombus. Cool. And we do have this reference sheet I think I showed you guys from the first unit that states all these definitions. Because you have to prove the sides are congruent in order to get the triangle congruence. So yeah, I know. Yes, you are 100% correct. And trust me, I felt the same way, and that's probably why I got a B in geometry. Only B I got in high school now was in geometry because I would skip these steps.
At the end
And now I teach it.
of the
But now more detail oriented, I'm, much older. So I was actually, yes. I was pretty upset. English I never got A's in, actually. Yeah. Actually, senior year I did because I liked that English class. Yeah. Yeah, I struggle with my writing. UC San Diego.
Wait, that's the public one, right?
Yeah. And there's San Diego University of San Diego. That's the Catholic school, right? That's down there. Hmm? It is actually. Actually, no, I did fine on like the SAT and like all the other standardized testing for geometry. I understand the concepts, just I just didn't write stuff down. That was my problem. I wasn't thorough, put it that way. Maybe. Yes. I don't remember. That's really bad. This is like 1993. You guys have like 33 years. No, the teacher's name.
Wait, what high school did you go to?
Mission San Jose High School in Fremont.
What?
Mission San Jose High School. About 30 minutes just in Fremont. Okay, I'll look. Her.
That's
Her.
like fun.
Okay.
What year were you 1993.
Ninth. Well, it was ninth. Well, I graduated in 95, but anyway, guys, let's focus on this. You guys could do your creepy social media stuff later. Let's okay. Okay. Hey, let's keep going. All right. Actually, I do remember. It was her last name was Dilmuth. Yeah. Yeah, that's because her daughter was in our class also.
Spelled like D-I.
Yeah, I think that's was. Yeah. That's yeah, Matt, that just came back to me. So it was yeah. But she actually I think only taught for 2 or 3 years. She didn't teach very long. So anyways. Actually my freshman year teacher was also my calculus teacher my senior year. She was really great. Her name is Claudia Fort, and she's actually very well known in the whole math teacher world. And then my pre-calculus honors teacher, her name was Julia Dunkel, I think. Yeah. Wait, what are you searching? Oh, you searching? Are you searching like the Mission San Jose Facebook page? I don't know who that is. I don't know who that is. No, don't know that. No. November 13th, 1977 is my birth date. So I'm 48 years old. Yeah. So
Love Mr.
that was that. No, you're talking about creepy. Yeah, that guy was super creepy. Yeah, he had an inappropriate relationship with a student. When I was in school there, yeah, it was yeah, and his wife also worked at school too. Yeah, yeah. Oh, I'm sure they did. Yeah, yeah. That was when I was in high school many years ago. One of the PE teachers, guys, we're getting so off track. And you guys even go to that school. Like, why would you guys even care? If you guys want to gossip about this school, I'll give you gossip about this school. You guys want, but let me finish. Okay. I think you guys are more interested in our own school than another school. Okay. And okay. Well, and whatever you guys want to know, we'll just close the door. I'll tell you whatever I want. Okay. But you need to let me get through the lesson, please. Thank you. And I'm just recording as well. Like I might get fired. Okay. Wait, who? Wait, who? What's what's the last name? I don't know who that is. Yeah. Yeah. But there's a lot of because my brother also went to the same school, so there's probably a lot of people from my brother's class were 3 years apart, so younger. But he looks older than me. He has all the gray hair. Yeah, we actually look almost identical. So yeah, there are times where people see my brother, they'll think he's me and vice versa. So yeah, he's like a doppelganger. Hmm. All right, guys, I want to finish the problem. Okay, guys, I'm just gonna keep going. So we're gonna keep moving, guys. Thank you. All right. But I definitely have a lot of historical knowledge about school if you are curious. Okay. Okay. Coming back to this. All right. So you have a rhombus, right? All four sides are the same, but it also means you have two pairs of congruent sides, right? Because PS and QR are the same, they're opposite of each other. PQ and SR are the same, they're opposite of each other. So you could say that. That's definition of rhombus. You have a reflexive because both triangles use PR, right? And if you have three pairs of sides that are all the same, what can you say is the reason? Side, 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 right? Yep. So that's how we can prove that triangles are congruent.
Are we done now?
Don't that proof.
We don't everything else. I want to hear about all the tea on the dues. All the good stuff.
All right. Okay.
Are we going all the way to down to back?
We're doing up to page 5.
It says discuss with the class all extended to.
Yeah, we're in there right now. Yeah.
It says. It
Discuss what, sorry?
says discuss with the class how to extend your.
Oh, proof. Oh, yeah. Okay. So actually, let's come back to this one more time. Let me not erase this. Here we go. Okay. So part D. I'm not going to show it because I want to keep the proof exposed here. How can you extend this proof? Okay, because part D is asking you, how can you extend this? You can extend it by using CPCTC. So for part D, it's asking you, how can you extend this proof to prove other things? See, if regular triangles are congruent, can you prove that this angle is the same as this angle? Sure. For what reason? CPCTC, right? And then, after you prove those angles are congruent, can you prove these sides are parallel? Yes. And for what reason? Alternate interior angles, right? So when part D says, discuss with the class how to extend the proof to get more things from this, right? To prove other things. Yeah, you could probably do a CPCTC for the angles. And then alternate interior angles congruent for parallel lines. So that's how you can prove all the sides are parallel once you've proven that the angles are the same. But how do you get to the angles being the same? You have to prove the triangles are congruent before that, right? So that's why they're parallel. Reagan, go ahead.
Can you choose parallel instead of like adding the lines event, or would you take points off if you didn't say like parallel line?
You have to say parallel lines, yeah. Do you not do your quiz?
Or I don't know, but
okay. That's okay. I just make a habit of it. That's all. All right. Let's move on to 762. All right. So just give my little voice a break. Cam, can you read 762?
Now that you know the opposite of the wrong is parallel, what else can we prove about a wrong? Consider this as the answer to the question below.
So here's what we're going to say. We're going to say the diagonals bisect each other. So I'm already giving the conclusion. So spoiler, I'm already telling you what's going to happen. But let's figure out how that happens. Why does that happen? So when it says, what do you think is special about AC and DB? They bisect each other. So actually, I already answered that for you. So what do you think is special? They bisect each other. They're also going to be perpendicular. So diagonals bisect each other. And what's special about AE and CE? Those are the same. And those are the same. So congruent. Congruent. Here what? Oh. So, oh, good. Yeah, go ahead, yeah. So use your observation part A to write conjecture or 2 on the relationship. So we're going to say AC and DB are perpendicular bisectors of each other. Now we have to prove it. So it's going to be a pretty lengthy proof. And we're definitely going to do some triangle congruent stuff, 100%. So get ready for it. But let me know when you're ready for me to move the screen.
Or B, E, and D, E, and C, E, and A, E, being the same, you haven't proved that yet, right?
We're going to. We're going to. Okay, and what's called, let me draw that again. Because I'm going to need this drawing. I'm just going to redraw this rhombus. Yeah, right, correct. We are. Okay, we're gonna say A, B, C, D is a rhombus. That's given. I don't know how many steps we're gonna have, but we want to prove that AC and DB are perpendicular bisectors of each other. I don't know how many steps. There's gonna be a lot of steps, I think. Okay, the first thing I need to establish is that these triangles are congruent. That's the first thing I need to establish. So, excuse me. So what I'm going to wind up doing is I'm going to state that AD is congruent to AB. Hold on. Is that right? Yeah.
Can you just like say the lines are parallel or is that out?
No, we can. We can. You're right. Yeah, we can. Yeah, we can. Okay, so that's well, hold on, I meant to say AB. My apologies. AD congruent to AB. And that's the definition of rhombus.
Also,
No, because we're given this one as a wrong. I mean, yes, we assume that, but that's the most logical step that comes after that. Yeah, cool.
is
That's fine. Yeah, but I'm because let me I'm just doing it this way because I want to prove that two particular triangles are the same, just so it's not too confusing. Also, what else do I know? I do know that AE equals AE. And that's going to be reflexive.
A equals A, or is congruent?
What does it start? Say again?
A is.
Congruent to AE. Yeah. So that's reflexive. Now, I could say, oh yeah, I got this. Angle BAE is congruent to angle DCE. What's the reason for that? Yeah, good. Awesome. Yeah. Because we already know the parallel. So we can go with that. Actually, you are right. I'm gonna squeeze in step two. You are correct. We should say that. Make faith. But I'm just gonna combine step two because it's all part of the same reason. But you could do, yeah, we do have to say that. You're 100% correct. Okay.
Is it a
I'm gonna get there in a moment. Yeah, just
AB isn't parallel to an AB?
oh, you're right. You're right. AB to DC. My apologies. You're right. You're right. Sorry about that. Thanks again. Sorry, my apologies. You are right. Guys, correction for step two. Yeah, DC and AB. My apologies. You're right. Because that's what we're using. You're right. So we're using this. Now here's the other thing. I also know that this angle is the same as this angle. I know that angle DAC, or also called DAE, whatever. Angle DAE is congruent to angle DCE.
Sure.
Yeah.
You have a charger at your desk?
Yeah. Actually, it reaches. There's actually one in the back. Yeah, because that one right there. Okay. So here's the reason why these are the same. You already established. Actually, hold on a sec. I think I'm saying. Give me one sec here, because I'm trying to prove something else that's congruent. Hold on. No, we're good. We're good. The reason why that's true. Yeah. The reason why that's true is because angles opposite congruent sides of a triangle are congruent. Does that make sense? When you have a triangle, when you have an isosceles triangle, if these are the same, those are the same. So we know that AD and DC are the same. We already know that.
How is, I'm just like, all steps are like, like, how is that step gonna, because what triangles are we trying to like prove the distance?
We're trying to prove that AED is the same as triangle AEB.
So why was step
For step 5, because I'm going to prove, you'll see why in the next step. It'll be clear. Not necessarily, but okay. Okay, guys, let's back up a little bit. So let's back up. So ABCD is a rhombus. Cool with that. All the sides are the same. All sides are parallel. Cool with that. AE equals AE. We're cool with that. That's reflexive. We did parallel line stuff, right? BAE, DCE have to be the same. Also, this is the part where I think I may have lost you guys a little bit. DAE and DCE, because they're opposite congruent sides of a triangle, they have to be the same as well. Now, Faith, to answer your question, why do we care about that? Angle BAE is the same as angle DAE because they both equal the same thing. They both equal DCE, right? So we call that substitution. Because what you're doing is you're replacing DCE. You're deliberately substituting for DCE, DAE. So you're replacing DCE with DAE. So those are the same. Now we know triangles are congruent. for step 7, I know that triangle DAE or triangle BAE, whatever you want to call it, is going to triangle DAE. So what's happening is that this triangle is the same as that triangle. That's DAE. And that's BAE. So I'm proving, just so, yeah, because I mean, I think that's a great question. What are we trying to, we're trying to kind of prove here, this one's the same as this one. How am I able to do that? I already know these sides are the same because depth of this reflexive, I know this. The tricky part was proving these angles were the same. How do I do that? What I did is I did, these were the same, by alternating your angles. These were the same, so opposite congruent sides of the triangle. Therefore, these have to be the same. Because if this equals this, and this equals this, then these two have to be the same. They both equal this one. If that's true, how are these triangles congruent? This one, side, angle. SAS, good, thanks. So let's be SAS. At that point, I know I've kind of run out of space here. No, it's going to be too much. That's going to be too much. I don't want to do that. Because I just realized how overwhelming this proof's already getting. So let's alter what we want to prove. Let's just prove that DE equals BE. Let's just prove that.
Is that Steve?
Correct. Right. So once you know those equal each other, then of course they bisect, right? And we could leave it at that. That's fine for now. Because more I think about it, this is going to be one of like being a 12 to 13 step proof. That's a little too much.
Do you think there'd be something?
Not quite, because that's a little too much.
Yeah.
But it's just to prove why they bisect each other. Once we have that established, we can use that. So now you can just use it. Now just know it. The diagonals cut each other in half. That's what I was trying to get across. Okay, let's move on. One more page. Okay. So there are many ways to prove a conjecture. You've rotated triangles to create parallelograms. You use congruent parts, subcongruent triangles, justify opposite sides of parallel. Is there another way? Science wants to prove the conjecture of quadrilateral is a parallelogram. The opposite angles are congruent. Okay, that's going to be a CP-CTC again. So here's what we're going to do. I'm going to draw that. And I think what I'm going to wind up doing, I'm going to do something called a paragraph proof for you guys. I'm going to do something a little different for you guys. I'm going to just talk it out. And I'm just going to transcribe as I'm talking. I think that might be a little better for you guys. And then you can go 5 minutes of juicy gossip here. Juicy gossip. Okay. I'll turn off the recording. So I don't get, so it's not, no record. Okay. Here's what we're going to do. We know that TUVW is a parallelogram. Okay, you're told that. That means that TU and WV are parallel, and TW and UV are. I'm not doing a 2-column. Excuse me. I'm not doing a 2-column proof. I'm doing a paragraph proof. A paragraph proof is a little different. Yeah. I'm talking it out. And actually, if it helps, I'll kind of do it more bullet point.
Yeah.
Oh, good. All right. So I'll kind of do it by bullet point. So we know that TUVW is a parallelogram. TU and WV are parallel. TW and UV are parallel. Cool. So here's the deal. Angle A is congruent to angle B because of alternate interior angles. Yeah, because I needed to. Yeah, I need to add that transversal. Yeah. No, we need to add it. So you could add that to your proof. It's called an auxiliary line, but if you just draw it, it's good enough for me. Just so you can help make the statements. But do we need it? 100% we need it. Yeah.
You're allowed to just add it.
Correct. Yeah. Yeah. But 100% we need to be able to prove that. Here's the other thing. Also, B is congruent, or I'll say C, no, I'll say B. B is congruent to C because they are corresponding angles. You guys remember corresponding angles? So, like when you have parallel lines, see how B and C are also corresponding? So, that means that A and C have to be congruent since both of them are congruent to B. We call this the substitution property of equality. Because you're substituting for B, you're replacing B with A so that A could equal C. It's kind of like, for example, I don't know, say we're talking about like some sport, I don't know, like say girls soccer. So let's say we beat Menlo, Menlo beat St. Francis, so we could beat St. Francis. It usually doesn't happen, right? Like there's all different matchups, but it's kind of like you're saying something kind of like that in a way. You're doing a comparison. So therefore, that's my last bullet point. Yeah, sure. Opposite each other in a parallelogram must be congruent. Yeah, it's a lot, but it does help explain the logic. Instead of writing as a two-column proof, if we just talk it out. So when you ask how I got a B in geometry, I could do this. I was cool with this. It was a formality that I just, sometimes botched. Because there's a formality, as we know. You got to state the right reasons, all those things, and whatever. But does that make sense for the logical flow? You got parallel lines, you got alternate triangles, you got corresponding angles, you got these angles that are the same. You got comparison between A and C. So that could prove it. So that's what's happening. So it's saying like, so actually I didn't necessarily use CPCTC. What I wound up using was substitution. So I didn't have to prove any triangle congruence. I could have, I suppose, but I didn't think that was necessary. I think this is a better way to do it. So yeah.
Now, all those students we can say what we proved as like a reason, like for example, like
Yeah.
have a parallelogram, we just like automatically like.
Yeah, because you're building on your previous knowledge, yes. Yeah, now we know that. Right. Yeah. Now we know that. So okay, so homework, just so you know, is going to be this. I need to put this in Schoology, but this is our planning document that we keep. So it's a bunch of textbook problems. Yeah, so a bunch of textbook problems there. So anyhow, I'll post the Schoology. Okay. Now you guys can ask